Let's derive a mathematical expression for work done during an isothermal volume change. Consider a gas in a cylinder of cross-sectional area A fitted with a movable piston. Due to the pressure of the gas P, a force F is equal to PA is exerted by the gas on the piston. This results small upward piston displacement dx. For this dx, work done by the gas is dW is F dot dx. R can be written as pressure into area into dx. Also, A multiplied by dx shows volume increase dV. Therefore, dW is equal to pdV for a small volume change. While for finite volume changes from V1 to V2, work done can be calculated by integrating it over the volume. Using ideal gas equation PV is equal to nRT, we can find that P is equal to nRT over V. Due to the isothermal process, T is constant and thus nRT is constant. Therefore, PV is constant, or we can write P1 V1 is equal to P2 V2. Also, we can write it as V2 over V1 is equal to P1 over P2. The expression for the work done by the gas for finite volume changes can be calculated by substituting value of P in this equation, integrating 1 over V over the volume from V1 to V2, and after applying upper and lower limits, we reach to the expression in terms of volume, that is W is equal to nRT log of V2 over V1. This equation can be modified in terms of pressure, that is W is equal to nRT log of P1 over P2 by employing the equation V2 over V1 is equal to P1 over P2. Both expressions can be evaluated. Log of a value greater than 1 always gives positive sign of the values. As in isothermal expansion, V2 over V1 and P1 over P2 are greater than 1, therefore work done by the gas is positive, which shows that work is done by the gas on the piston. Similarly, in isothermal compression, V2 over V1 and P1 over P2 are less than 1, therefore work done by the gas is negative, which shows that work is done on the gas by the piston.